please add your name to the chat for attendance. By the way, there was a typo on the quiz due date. It was writing 11:59 a.m., but it's supposed to be p.m. So don't rush. You have till midnight tonight to finish the quiz. Okay, today I'm going to look at section 8.5, chi-square test for variance and standard deviation. I'm going to look at some homework assignment. You have the PowerPoint if you have questions, but I'm going to look at several homework assignment. Okay, so let me share my screen. So we are looking at section 8.5, hypothesis testing for variance and standard deviation. The first problem that I'm going to check from sections 8.5 is problem number 7. Problem number 7, 8.5. The manager of a large factory claims that the standard deviation of the time in minutes that it takes a telephone call to be transferred to the correct office in her company is 12.2 minutes or less. So first of all, since we are talking about the standard deviation, a parameter is standard deviation sigma. And the claim is that sigma is less than or equal, because it says they claim that the standard deviation of the time that takes a telephone call to be transferred to the correct office in her company is 1.2 minutes or less. So it's less than or equal 1.2. Your n is 12. The standard deviation of the sample S is 1.8. Alpha is 0.01. We're going to use p-value method. So when the parameter is variance or a standard deviation, we're going to use chi-square test. So our claim is sigma less than or equal to 1.2. So where do I put this claim? Does it go with the null hypothesis H0 or goes with alternative hypothesis H1? Now, since your claim has less than or equal, any symbol that has equal sign attached to it, like equal, less than or equal, greater than or equal, goes to null hypothesis. So since our symbol has equal attached to it, so we put this claim next to null hypothesis. Here is null hypothesis, sigma less than or equal to 1.2. Last week in class, I mentioned that every time you have less than or equal or greater than or equal, the author write sigma or mu or p equal your k. So I put less than or equal, then author version, sigma equal to 1.2. You don't have to put the author version. You have to put in front of your claim, HO, write this is a claim. So you know this is H0 is a claim for the later. Then what is alternative? You have to put sigma opposite of less than or equal greater than 1.2. Okay, what type of tail test do we have? You look at the direction of H1, mu greater than 1.2. So we are looking at all the number to the right side of 1.2. So we have a right tail test. Okay. Now, I gave a handout last time in class. If you were in the class for the formula sheet, I gave you a formula sheet handout, and I gave you a handout called p-value, critical value, and confidence coefficient. If you were in class, you have those two handouts. If you were not, if you don't have that handout, please inbox me after class or email me, and I'm going to send you both handouts. It's very useful for it, put everything together. Now, they're asking us to use p-value method. For the p-value method, the second step of hypothesis testing is calculating a test value. And by the way, I put the step numbers inside a box. And I want everybody to do that when you are doing your homework, quizzes, and exams, especially quizzes and exams, because I have to look at so many steps, okay? So you look at the formula sheet for chapter 8, and you find, since we are using chi-square test, find the formula that starts with the symbol chi-square, and that would be the test value for chi-square, so test value. Your test value depends on the parameter, which is a standard deviation, and your test, chi-square test, and your parameter. And from the formula sheet, this is your test value formula. Chi-square is n minus 1 times s to the power of 2 over sigma square. Okay. N was 15, so you get 15 minus 114 times s to the power of 2. So you get 1.8 to the power of 2 divided by sigma. Sigma is in your HO sentence, 1.2 to the power of 2. Enter this in the calculator. You don't have to put parentheses around the numerator and denominator because you have multiplication and division. So you get 31.5. Okay. Then for the third step is to find p-value. To find the p-value, you have to look at your distribution test, chi-square test, and what type of tail test do you have? Tail test do you have? So to find p-value, you have to depend on two information, your distribution test, which is chi-square, and your tail test. So you go to CV, PV, and confidence coefficient. The handout is called CC, confidence coefficient, PV, p-value, CV, critical value. Go to that handout, find p-value for chi-square test, and find the right tail. So p-value is chi-square CDF, chi-square, which is your 31.5, positive infinity E99, and degree of freedom, which is n minus 114. So can you write this formula, Shana? P-value is equal to chi-square CDF.
P-value is equal to chi-square, okay.
CDF, 0.5.
What was that?
31.5.
31.5, okay.
Comma, positive infinity.
Right.
Comma, 14.
14, got it.
Yeah, I'm going to stop sharing my screen and bring my calculator out.
Mm-hmm.
So I go to distribution. Second wars gives me the distribution. I pick item number 8, chi-square CDF. Lower is
31.5.
Thank you. Upper positive
E99.
infinity, so
Uh-huh.
E99. Degree
And
of freedom,
14.
14. Paste. 0.00472. Okay. Any question?
Remember, degree of freedom is 1 less than n here.
Yeah, n minus 1, 14.
Still. Okay.
Okay, I'm going to stop sharing my window, go back to my example. So 0.0047. So that's my p-value. The third step is to decide if we have to reject or not reject null. Okay. With the p-value, to make that decision, you're going to compare your p-value to your alpha. Compare your p-value to your alpha. I always write p-value on the left side, and I write my alpha on the right side. Okay. A p-value is 0.00 here, p-value. And my alpha on the right, p-value on the left, alpha on the right. The p-value is 0.0047, alpha is 0.01. I see that my alpha is larger, okay? So the amount of my inequality is toward larger number, alpha, okay? So 0.0047 and 0.01, alpha is larger, so I will put the amount of my inequality toward alpha. Okay, now I read the sentence in 4 from left to right. I say p-value is less than alpha. When p-value is less than alpha, it means that my p-value is in the alpha region, which is critical region. Or if you look at the formula sheet or the lesson, if p-value is less than or equal to alpha, you're going to reject null. Why are we rejecting null? Because small p-value, when p-value is less than alpha, means your p-value is inside alpha region. Alpha region is a critical region. So we're going to reject null. Okay. Now, step 5, do our summary, right? Our summary. The summary, I gave you a table for your summary. Your summary depends what is your claim. From step 1, we know that our claim is HO. Okay. That's why I want you to write next to HO or H1, which one is the claim. Or in next to H1, write what type of tail test you have. You need it for finding the p-value or critical value. Okay, so your claim was HO, and you rejected HO in step 4. So I'm going to go to outcome of hypothesis testing. This is the outcome of a hypothesis testing. Claim is HO, and you rejected HO. So you have to write this exact sentence. There is enough evidence to reject the claim. And here is my summary. There is enough evidence to reject the claim. You have, I want you to, when you are writing your summary, step 5, I only want one of these 4 boxes, only one of them, exactly the same. Okay, exactly the same. You have to underline is, underline reject. If you have is not, underline is not. If you have, again, reject, underline reject. If you have support, underline. So one of the 4 boxes, and it has to be exactly the same thing. If there is an underlining, put it there. Any question?
Not seeing anything in the chat right now.
Okay. Okay, next I'm going to look at problem number 5. Problem number 9, sorry. from 8.5. Okay, let me share my screen. Problem number 9. No, sorry. 5. Problem number
5.
9 from the textbook, 5 from the handout.
Got it.
Potassium is important to good health in keeping fluid and minerals balanced and blood pressure low. High potassium foods are those that contains more than 200 milligram per serving. The amount of potassium for a random sample are shown at alpha equal to 0.10 is the standard deviation of the potassium content is greater than 100. Okay. First of all, your parameter is a standard deviation, sigma. Then claim is that at alpha equal to 0.10 is the standard deviation of potassium greater than 100, sigma larger than 100. Okay. N, I have not mentioned what N is, but I have given you raw data. Your raw data has N 8 potassium level. So N is 8. I went and put these number in my, I went to my calculator. I click the stat key. On the top row, I pick edit. Then under edit, I pick edit. So I enter my raw data in my stat edit table. And after I enter all those 8 numbers, I quit that window. Then I click a stat. Then on the top row, I pick calculate and 1 var stat. Okay. And my S was standard deviation, S or S sub X. In the calculator, you have to pick S sub X. When you have a raw data, please never pick sigma sub X. Always pick S sub X, which is the same as S. So standard deviation of those 8 samples is 126.721. And we don't need X bar. Okay. And again, since parameter is a standard deviation, we use chi-square test. Okay. Now, where do I put my claim? Do I put it with HO or H1? Now, since I look at my symbol doesn't have equal sign. Any symbol with equal sign goes to HO. Any symbol that doesn't have equal sign goes with H1. So I put my claim on H1. Sigma is greater than 100. I put claim. I have to write the statement claim next to H1. And what is my null hypothesis? I write sigma, I write 100, but I put the opposite sign of greater than. I put less than, and I put equal attached to it, less than or equal. And if you want, you can write author's equivalent. But if H or H1 is less than or equal or greater than or equal, I want to see that. But I don't care if you write sigma equal 100 or sigma equal. I don't care about that. Then I look at H1 statement, because that tells me what type of tail test do I have. Sigma greater than 100. I'm looking at all the numbers larger than to the right of 100. So you have a right tail test. Okay. According to the formula sheet, the second step, when you are, now this problem didn't tell you what method you should use, If on the exam or quiz, I will tell you what method you should use, traditional method or p-value method. But the textbook, if it doesn't mention a traditional method. If it doesn't mention any method, it is traditional method. Otherwise, they will tell you use p-value method, like the previous example that I look at. So for the traditional method, the second step is finding, wait, why am I using?
Traditional method.
Traditional method, you have to find critical value. That's all right.
Are you going to have them do that with the calculator or?
No, they have to use inverse chi-square. Okay, this is a step 3. Test value is a step 3. Critical value is a step 2. Okay, my step numbers are wrong. I have to fix it. So we have to find our critical value. Okay, depends on 2 tests: statistical test, chi-square, and the right tail test. You go to the handouts that I gave you on CC, PV, and CV, PV, and CC handout. And you go to chi-square test, critical value chi-square right tail test. You see that critical value is inverse chi-square of alpha and degree of freedom. I gave you a program in the classroom for inverse chi-square. So can you write the value of alpha and degree of freedom, Shona?
Sure, so 0.10.
And degree of freedom 7.
7, okay.
So let me stop sharing. Share my calculator. So I go click the program. I find inverse chi-square. You have to be on execute, pick inverse chi-square, press enter. Then it says program inverse chi-square, press enter again. Then it says right tail.
0.10.
0.10. Then ask me the degree of freedom.
7.
7. Then I have to wait. It gives me 12.01.
704. 12.01704.
Okay.
Remember, we only have one critical value here because it's a right tail
Yes.
pass. Okay, so you don't need 2 of them.
So 12.0170. Then the third step is finding test value. Test value depends on your parameter, standard deviation, and your name of the test, chi-square test. So you go to the formula sheet. From chapter 7, you pick the formula that starts with chi-square. Okay, the same formula as the previous example. I just plug everything that we have. N is 8, 8 minus 1, 7. S, we calculated with the calculator, 126.721. Sigma was 100. So chi-square is 11.2407. Okay. Any question? So remember, the step 2 that you see on the here, it has to be 3. The critical value has to be a step 2. Okay. Now we have to decide to reject or not reject null. Okay. With the traditional method, you draw your curve, chi-square curve, which is a positively skewed curve, and you locate your critical value on it, and you also locate the test value. So I drew my positively skewed curve. Okay. My critical value was 12.0170. That's the red line you see here, the small red line. And my test was a right tail. So I shade the right side of my critical value. The shaded region is critical region, non-shaded region is non-critical region. Then I put my test value on my graph, 11.2407. 11.2407 is less than 12.0170. So it goes on the left side of that small red line. The large red line is your test value. The small red line is your critical value. So your test value falls in the non-critical region. So you are not going to reject null. Okay? So do not reject null. Okay. Now, the last step are summary. So you have to know what your claim was. Claim was your H1, and you did not reject null. So I go to my outcome of hypothesis testing. Claim was H1 from step 1. And from step 4, I did not reject null. So there is not enough evidence to support the claim, and here is the sentence. You don't have to give me these outcomes. This box that I'm showing you is just for you guys to learn. But during the exam or quiz, you do not have to give me, but you have to know this and pick one of the 4 boxes for summary. Any question? Okay. If you don't have any question, I'm going to stop by sharing my screen. Let me see if the next example is similar to the other one. Yeah, I think I did enough. I pick enough problems for 8.5. Because if you were in class last time, we did like 7 problems from the homeworks, 3 different sections, and I did 2. So any question in general? I'm done with chapter 8. Okay.
Chapter 8 was hypothesis testing for one population.
Hypothesis testing for one population. When your parameter were mean, we had z-test, t-test. When parameter was proportion, z-test. When parameter is variance and chi-square, we had when parameter was variance and standard deviation, we had chi-square test.
And just to remind you, there is the video that went out last night. There is a review of how to find your null and your alternative hypothesis there. The video for 9.1 also includes, for about the first 5 minutes or so, a review of the tests and which ones go with which parameters. So you can look for it there, but there is video content for 9.1 and 9.4 that's already up. So you'll be able to find that. If you can't find it, email me. Okay.
Okay, I'm going to go over 9.1, the PowerPoint, maybe look at, I don't know how many examples is there. If I can finish it, that's fine. If I see there are too many examples, I will not do 1 or 2 of them, then I go and pick a homework problem. Oh, let's see.
And for those of you who came in to the meeting just recently, the quiz is due tonight at 11:59. There was a typo earlier. So the quiz is due tonight, 11:59.
Do you see chapter 9 screen?
Yes, ma'am.
Okay. Okay, chapter 9 is hypothesis testing when you have 2 populations. Chapter 8, we did hypothesis testing for one population. Chapter 9, hypothesis testing with two population. Okay? Two population. Again, we are dealing with the mean, proportion, variance, and standard deviation. From chapter 9, I'm only going to cover 3 sections. Okay? And for the mean, I'm only covering z-test. Z-test. Okay? Z-test. And also, I want you to do every single problem of chapter 9 using p-value method. P-value method. Only p-value method because we're going to use our calculator to find p-value and test value. Your calculator will not find critical values. That's why for chapter 9, I'm not using traditional method. Even if your book wants you to use traditional method in chapter 9, I want you to use p-value method. Is that clear to everybody? Okay. Okay, you can read slide number 3. How do we write our null hypothesis and alternative hypothesis when we have two populations? For a two-tailed test, the way you write your, let's look at the left side of this second line. Left side of second and third line. We are comparing two populations. We are doing hypothesis testing for two populations. So you are comparing their mean. In chapter 8, for instance, we says null hypothesis mu equal to 18, correct? Or mu for alternative mu not equal to 18. But there is no number anymore. We say that for null hypothesis, we say mu1, mean of first population equal mu of second population, mean of second population. Now, since our equation has equal sign, we put it next to null hypothesis. For alternative hypothesis, we write mu1 and mu2. We put the opposite of the equal sign, which is not equal sign. Okay? That's the way you write null and alternative hypothesis for two-tailed test. There is another version that you will you can write, which I usually write the left version. You can put both mu1 and mu2 on the same side by subtracting mu2 from both sides. So you get mu1 minus mu2 equal to 0. The same thing with alternative hypothesis. Subtract mu2 from both sides, so you end up with mu1 minus mu2 equal to not equal to 0. Okay, so I really like to see the first version on the left side. Okay, that's for the two-tailed test. For a right-tailed test, your remember the name of the tail test is in the direction of H1. So if you have a right-tailed test, your H1 is mu1 larger than mu2. There's no equal sign in our symbol, then null is mu1 less than or equal to mu2. Okay. So for the right-tailed test, null is mu1 less than or equal to mu2. The author's version, mu1 equal mu2. Then alternative hypothesis, mu1 larger than mu2. Now, if you want to write the OR version, which I don't recommend, put everything on the left side of your symbols. So null, mu1 minus mu2 less than or equal to 0. Alternative, mu1 minus mu2 bigger than 0. Then author's version for null, mu1 minus mu2 equal to 0. So we are comparing their mean. We are comparing their proportion. We are comparing their standard deviation. Well, this is the left tail test version. Null mu1 greater than or equal to mu2. Alternative mu1 less than mu2. That's why the name comes. The name of the tail test is in the direction of H1 all the time. Author's version for H1, not the OR version. And we put everything on one side. Any question? Okay. This is the test value when you're comparing two mean. You do not have to memorize this formula. You do not have to use it because the calculator gives you the value of the Z when we are using p-value method. So don't worry about this slide. We're going to get the value of Z from our calculator. X1 bar minus X2 bar is observed difference. Mu1 minus mu2 is always equal to 0. That's expected difference. You see it in null sentence. The same hypothesis testing for Z-test, traditional p-value method. The same steps in your formula sheet. At the bottom of the formula sheet, there are two gray boxes. N1 has to be greater than or equal to 0, N2 greater than or equal to, 30, N2 greater than or equal to 30. If we don't give you sigma 1 and sigma 2, you can replace it with S1, S4, S2, S4. Okay. Using the TI calculator we are going to use our calculator. Okay. So we are comparing two mean and we are using Z-test. Two mean, Z-test. So you click the stat key. On the top row, we have edit, we have calculate, we have tests, and we have something else. I can't remember right now. You pick tests. And under the test, you're going to pick two sample Z-test option. Two sample Z-test option. Then, if I give you I give you two sets of information. One set is I give you some statistics. For instance, I give you the mean of first population, standard deviation of the first population, sample size of the first population. Okay. Then for the second population, I give you the same. I give you mean, standard deviation, and sample size. So you choose stat because I have given you statistics, mean, standard deviation, sample size. So you pick, move the cursor to a stat, press enter. Type in the appropriate values. Whatever I have given you, you type it. This is when I have given you a statistics. And then you move the cursor to the appropriate H1. What do we mean by that? Because before we find our test value and p-value, we have to go through a step 1. Step 1 tells you that if you have to write your HO sentence, H1 sentence, you have to know which one is the claim and what type of tail test we have. So you put the tail test because we have HO. Then for H1, we have right tail, left tail, two tail. You have to pick a correct tail test. Put the cursor, move the cursor to appropriate H1. Again, I mean that you have to give them either two tail, right tail, left tail. Press enter. After you pick that, then move the cursor to calculate, press enter. Again, we will solve all assignment in this chapter using p-value method. Because the calculator, as I said, gives you test value and p-value. So no traditional method for this chapter. Let's look at the example. A study was conducted to see if there was a difference between spouses and significant others in coping skills when living with or caring for a person with multiple sclerosis. These skills were measured by questionnaire responses. The result of the two groups are given below. At alpha equal to 0.10, is there a difference in the means of the two groups? Use p-value method. So I have given you two groups, spouses and significant others. I have not given you raw data for each group. I have given you statistics, mean, standard deviation, sample size, mean, standard deviation, sample size. Okay. You don't see any raw data for these two groups. Here is the problem on the upper left-hand corner. So your parameter is mean. You're going to use z-test. What is our claim? It says at alpha equal to 0.10, is there a difference? So they're telling us, they're saying that the means are different from each other. The means are different from each other. It means that mu1 is not equal mu2. That's our claim. Mu1 for the first group, spouses, not equal mu2 of the second group. Mu1 not equal mu2. They're different. Is there a difference? We want to check that to see mu1. Is mu1 not equal mu2? And these are our statistics. Both of the n's are larger than 30. Is n greater than or equal to 30? Yes, z-test. So we are using z-test. So for the mean and large sample, we're going to use two sample z-test. That's the name of our test. Two sample, we don't write sample completely, two sample z-test. And I have given you a statistic, so you go stats. Okay. Now, before I continue, I have to write my step 1. So in a step 1, I have HO and I have H1. HO colon, below it H1 colon. Where do we put our claim? Do we put it with HO or H1? Since my sentence doesn't have equal sign, my claim goes with H1. H1, mu1 not equal to mu2. That's a claim. I have a two-tailed test. I discussed this in chapter 8 and 9. And what is my null? First, I write my claim sentence, in this case, H1. Then I write my null. Oops, what happened? Sorry. Then I write my null. HO is mu1 equal mu2. Okay. Any question?
The same rules for deciding where the hypothesis goes apply here.
Yes.
In this chapter. The only difference is how the null and the alternative are written, but we're still following the same rules for the keywords, for the symbols for your keywords chart that you had in chapter 8. We're still following those here.
I think we have it. I don't think I put it in chapter 9, but I start to put those keywords starting chapter 4. You had it chapter 4, 5, 6, all of the chapter, the first two.
And again, if you need more clarification on that, refer to the video that I posted last night, specifically on identifying the null and the alternative. All of those strategies apply here. It's just that your null and your alternative look slightly different in chapter 9 than they do in chapter 8.
Okay, thank you, Shauna. Okay, I'm going to stop sharing and bring my calculator. Okay, so let me clear my window. So we are choosing two sample z-test. So I go to stat, I click stat. On the top row, you have edit, calculate test. I'm going to go and highlight test. Two sample z-test. Two sample z-test, press enter. On the top row input, you have data and you have stats. Data is when I give you raw data for two groups, bunch of numbers for each group. But here, I give you a statistics for each group. I gave you mean, standard deviation, sample size. Okay. Here is this. Now, since we have using, so I highlight the statistics, I go and say sigma 1. I have not given you sigma 1, but I have given you S1. You can replace sigma 1 with S1, 0.6. Then it says sigma 2, so replace it with S2, 0.7. Then it says X1 bar, X1 bar 2. N1, 120. It is given to you in the problem. Then you get X2 bar, 1.7. N2, 34. Now, then it says mu1, colon, then you have not equal mu2, less than mu2, greater than mu2. Here, on H1 sentence, we had mu1 not equal mu2. So I go down, highlight the first option, mu1 not equal mu2. I'm telling the calculator I have a two-tailed test. I press enter. And I go down, go down. You may not have color. Highlight, calculate. So two sample z-test. Mu1 not equal to mu2. This is, I'm telling the calculator, I told calculator two-tailed test. The first number is my test value. Can you copy it down?
Oh, hold on, let me grab it really quick. Okay. I haven't, because I'm on the other screen right now. Give me a second. Let me see. Where is my, let me follow that. So I have
27353.
2.27353.
And P is 0.02299.
0.02299. Okay.
So the first number Z is test value. The second number is P value. You don't need to do. You already have the other numbers that they have.
Yeah, you don't need that. Okay.
So
you're frozen, Professor. Hold on, I'm frozen. Yeah. Am I frozen? Let me see. Where is my shoot. Where's my network?
230. Alpha 0.10.
Mm-hmm.
I see that my alpha is larger, so the amount of my inequalities toward alpha.
Mm-hmm.
And I read my sentence from left to right, p-value is less than alpha. So I'm going to reject null because p-value is falling in the alpha region, which is critical region. So reject null. So you see that for a step 2 and 3, you don't have to use any of the formulas. Okay. Now the summary is the flowchart that I gave you. My claim was H1, mu1 not equal mu2. And from step 4, I rejected the null. This was the outcomes. You have to pick one of these 4 outcomes. Claim is H1, and you rejected null. So you write there is enough evidence to support the claim. And don't forget, underlining is and support. That's an example. Okay. Let me see what is the second example. Okay. Any question about a previous example? Example number 1. Okay. Now, what happened if your parameter is the mean and you have 2 populations, instead of giving you for each population mean, standard deviation, sample size, I give you raw data. So first you're going to click the stat key and you're going to, before that, you enter your first set of raw data. You go to list, you go to edit. You enter your first set of raw data in list 1 and second set of raw data in list 2. And when you do that, okay, I think, okay, you do that. Then you leave that window by quitting, second mode quits, then you click a stat. And this time, instead of going to edit, you go to test. And you select 2 sample z-test. But this time, under 2 sample z-test, again, you have the input, you have data, and you have statistics. This time, you're going to pick data for your raw data. Okay? You pick data. Okay, it says type in appropriate value. After you enter, let's go back to list 1. After you enter your raw data in list 1 and list 2, okay, let me show you. Hold on a second. You go to, you quit that window, edit window, you click the stat key, then you pick value, edit. What is the other option? Hold on a second. Okay, let me bring my calculator.
Stat edit. Calc is there too. Stat calc.
Oh, calc. I forgot the word calc. So let me clear this. So you click stat key on the edit. You pick edit. You enter your raw data in list 1, list 2. I don't think these are the same numbers. Let me see. No. Okay. You enter your first raw data in list 1, second raw data in list 2. Quit, second mode quits. Then before you go to step number 2, you click the stat, you go to calculate. You pick 1 var stat. first list, for list you put L1, ignore frequency list, calculate. Then from one word stat for list one, pick X bar and S sub X, only S sub X, okay? Please do not pick sigma from one word stat. Never pick sigma from one word stat, please. You do the same thing for list two. You go to stat, calculate, one word stat. Under list, you put list two. Next to list, you put list two. Then you pick X bar and S sub X from that window also. That's after, okay. Let me quit. So maybe I do the following. Add another step to this. To push stat, then calc, one word, stats, then list, L1, choose X bar, and S sub X. Okay. This would be step 3, step 4, 5, 6, 7. Do the same for L2, for list 2. Okay. Okay, here at data, type in the appropriate value. When it says type in appropriate value, you need for list 1, I think you have to put your X bar, your S sub X, and N also. Choose an N. You need sample size. N, and you do the same thing for L2. So let me. Okay, choose X bar, N, and S sub X. And then you go down and you go to move the cursor to H1 because it says HO colon. Then you have to pick appropriate H1 symbol. It means right tail test, left tail test, two tail. And highlight calculate, press enter. Okay. Okay, let's look at this example. Shauna, do you have your calculator in hand?
I don't. I have the emulator, but I don't have my calculator here. No,
Okay.
I don't have it.
While I'm going through step one, can you enter, if you can you enter your raw data, Birmingham raw data in list one,
Birmingham.
Chicago in list two of your?
I'm actually getting questions about the quiz right now.
Uh-huh.
So I'm trying to answer that. Just to let me interject, if it would help anybody, I can have a meeting tonight. Normally I wouldn't, but I can open up a meeting tonight if you guys need extra help with the quiz.
Let me ask you, is the students right now asking you question about the quiz in chat?
No, they just asked if you're gonna have us write the parameters on the quiz. Like for the name of the parameter on the quiz. So yes, you're going to write those on the quiz when you have it.
Okay.
So for those of you who would like to have a meeting, let me know before the meeting is over. So that
Okay.
I'm gonna work on this here. Let me see. Let me open.
Okay, I can do that myself, Shauna.
Okay.
The average temperature for a 25-day period for Birmingham, Alabama, and Chicago, Illinois are given. Here it is. That's raw data. The temperature for Birmingham and Chicago. At alpha equal to 0.10, can it be concluded that the average temperature is warmer in Birmingham? I have given you sigma 1 and sigma 2 for each group. These are population standard deviation. We want to use p-value method. Okay. First of all, the alpha synthesis says, can it be concluded that the average temperature is warmer? So the parameter here is mean mu. When the temperature is warmer, the temperature is higher, correct?
Yes.
So saying that is the temperature for Birmingham larger than temperature for average temperature for Chicago. So the claim is that mu1 average temperature for Birmingham larger than mu2. Okay.
Pull up.
Okay. 1, 2, 3, 4, 5. We are going to use a z-test here, okay, because I have given you sigmas. Is sigma given? Yes, we're going to use z-test. So we're going to use 2 sample z-test data. Okay. I'm going to put my claim with H1 because my inequality symbol doesn't have any equal sign. So H1, mu1 larger than mu2, that's my claim. This is a right tail test because mu1 larger than mu2. Then my null hypothesis, null, mu1 less than mu2. And that's outer version, mu1 less than or equal to mu1 less than or equal mu2. Now, to find p-value and test value, I have to enter my raw data in the calculator. Let me do that.
Please mute your microphones, people. We have background noise. Please be respectful and mute your mic. I can't do it myself, or I would.
Okay, so I'm going to go to a stat. edit. I'm going to put Birmingham temperature in list one, 78, 82, 68, 67, 68, 75, 73, 75, 64, 68, 62, 73, 77, 78, 68, no, 77, 78, 79, 74, 72, 73, 78, 68, 73, 79, 82, 71, and 66. Okay. So this is information for list one for Birmingham. You do the same thing for Chicago. So I only did for list one. So then you quit. This is a step two. You click the stat key. You go to calculate. One word stat, list one. You enter list one. Highlight calculate. You pick X bar. You pick S sub X and you pick N. Okay. X bar, S sub X, and N. Then you do the same thing for Chicago list two. Okay.
Professor, can you check your chat, please? I sent you a direct message.
Okay, hold on a second. I want to finish this example, then check mine.
That's fine. It's important, but it's not urgent.
Okay. So after I put the, so, okay, let me go back again. Stop sharing. Let me go to my calculator. Okay. After I pick the information for list one and list two, I click stat. I pick my tests. I go to sample Z test. This time I had data. I press enter. Then it asks me what is your sigma 1 and sigma 2. Sigma 1 is 5.39. Sigma 2, 5.70. If I don't give you sigma 1 and sigma 2, you need your S1 and S2 from calculate window, okay? If I don't give you sigma 1 and sigma 2, you need S1 and S2 from calculate window. Now, they are not asking for N and X bar. So list one is L1, list two is L2. Frequency, you can either leave it blank. Okay, they want a number, let's just put 1. If they want a number, put 1 for frequency 1, frequency 2. And for mu1, we have to, we had mu1 larger than mu2, correct? Right till test. So you go to this one. You pick mu1 because the Birmingham temperature was warmer, so it was higher than Chicago. Mu1 larger than mu2. Calculate. Quit. What was the error here? Let me see.
Error syntax. Try go to. I don't know what your syntax problem
I don't know what is my syntax.
is either.
Maybe one. I put one also.
Maybe
Oh, okay. I know what's the
leave those
problem
blank.
because I only enter raw data in one of the list. Okay.
Mm.
You have to enter because I don't have enough time. I put only Birmingham in list one. I didn't put the information in list two. Maybe just I'm going to quit from this window and just put. I'm just going to
Do you
make
have the
numbers
solution that you
I
can
have the solution. I just want to tell my students what they have to. Okay,
got
I
it.
just put arbitrary numbers here.
Like
Now it's going to work.
like
Now, since I have information list one, list two, I'm okay.
then it should be okay.
Now I should be okay because now I have
Amazing.
numbers in this too. But remember, the number that I'm going to highlight, calculate, press enter is not going to be the correct numbers because I put fake numbers in this too.
There we go.
Here, this is a fake. You need Z and you need P. But these are fake numbers because I didn't enter correct Chicago numbers in list two. Okay. But when I did it properly, my test value Z was, come on, go away. My test value Z was 1.3512. My P value was 0.0883. Okay. Then I have to decide to reject or not reject null. I'm going to compare my P value with alpha. P value is 0.0833. Alpha is 0.10. Alpha is larger, so mouth goes toward alpha. Read descendants from left to right. P value is less than alpha. So you're going to reject null. My claim was H1, and I rejected null. Claim was H1, and I rejected null. There is enough evidence to support the claim. Okay. Any question? Okay, I'm
not about this, but if you could check your chat.
okay.
It's not something that I can address here with people here.
Are you talking about the students working?
There's two students that have the same.
Okay, we have two students who have to work directly after this.
So I told them to inbox you.
Yeah, they can either inbox me. They have question about the quiz.
It's more like work schedule situation.
Okay, I don't understand, but they can either inbox you or me, and we can help them.
So if you're still here, let me see if they're both still here. Because remember, Professor Nikdel has an office hour.
Yeah, I have office hours from 1 to 2 Zoom.
Today, so inbox her during that period and she'll get back to you about it, okay? I will, as far as those of you who wanted a meeting today, I can't meet before this evening. I have things that I'm doing today, but I will send a class message when I'm no longer available to answer you. So when I shut down for the night, I will Canvas message you and let you know that I have shut down for the night tonight.
Okay. Now, you also, If you remember in chapter 7, we look at finding confidence interval for mean, proportion, standard deviation, variance. Now here, we're going to find confidence interval, but you don't have to use that big formula. The calculator will give you confidence interval, okay? So this is confidence interval when you're comparing two means. Okay, this is, you don't have to worry about this formula. I'm going to show you how to find the your interval from with the calculator. Can you see my screen?
What we're seeing right now is the TI 8483
that's the one.
confidence interval.
Yes. So to find the confidence interval for the mean, again, you have two options. One statistics, one raw data. So this time you go to a stat, you go to test. Instead of picking two sample Z test, you pick two sample Z int. Int is for interval. Two sample Z int. So we have two groups. You're using Z test and you want interval. For hypothesis testing, you had two groups. You were using Z test. You're doing hypothesis testing. Two sample Z test, two sample Z int. Then if I give you if I give you a statistics, you move your cursor to a stat. You have two options, input stat data. Then for confidence interval, you give them confidence level, like a 90% confidence interval. You put 90 or 95 or 99. Then move the cursor to calculate, press enter. Okay. If you have raw data, enter your data in list 1 and list 2, then get the go to calculate one var stat, pick x bar, s sub x, and n. Okay. Then quit that window, go to a stat test, pick two sample z int, move the cursor to data, press enter, put your confidence level, 90%, just 90 or 95 or 99. Then highlight, calculate, press enter. Okay. Okay. Two brands of batteries are tested and their voltage compared. The data shown below, find a 95% confidence interval of the true difference in the means. Assume both variables are normally distributed. So we are finding confidence interval for difference between two means. So we have to say mu1, mu2 between two numbers, mu1, mu2 less than a number, larger than another number. I have given you a statistics for two brands of batteries, brand X, brand Y. These are statistics. So our parameter is mean, mu. We are using two sample Z int, two sample Z int. Two sample Z ints. Okay, let me. So you click stat tests in the top row. At the beginning, you have all the tests, Z test, T test, two sample Z test, two sample T test, one proportion Z test, two proportion Z test. Then 7 and on start with interval. So you're going to pick two sample Z int interval. Number 9, two sample Z int. I have given you a statistics. So you go to a stat on the input, highlight the stats, go down. Sigma, I have it. You don't have sigma 1, you have x1 9.2. sigma 2, sorry, I
No, that's
I
not,
entered wrong one. Instead of sigma 1, put, yeah, sigma 1, I already have given you 0.3.
but it's, yeah.
Sigma 2, 0.1. X1, 9.2. N1, 27. X2, bar, 8.8. N2, 30. We are finding 95% confidence interval. For sea level, I point 0.95. Okay. You have to put the percent, the decimal value. 95% is 0.95. Then highlight calculate. Here is your confidence interval. You don't have to use that big formula. Did I stop sharing my calculator?
Yes, we're seeing your screen. Now
Okay.
we're seeing your solution for
Yes.
the,
So the first line inside the parentheses, so you have parentheses, 2 numbers, that's your interval. So put the first number inside the parentheses on the left side, put the second number inside parentheses on the right side. Okay. Okay. Any question? Before I go to 9.4, any question on the quiz?
people were asking about, I'm just gonna direct your attention to that, if she's asking for the parameter, because I got this question from
yes.
more than one of you.
I think,
Parameters
okay, Shana,
are,
can you hold for a second? I think on the format of the quiz, if it says parameter, like on the homework, on the slide, I don't know, if I ask you to put, I ask parameter, yes, I need parameter. If I didn't put the word parameter, don't give it to me.
no, that you did, but they're asking about whether you want the words or the numbers. She wants the words.
Yeah,
The
mean equal
the-
mu.
The numbers come under given values. When she asks you for given data, that's where you put the numbers.
Yes. Okay, parameter, you have to put, let's say, mean mu or proportion p.
Just like she did on the slide. Can you put the slide up that you had?
Okay.
And the parameters are going to be, so here she writes mean
Parameter.
equals mu. That's what she's talking about. If there's a mean, it's going to be mu. If there's a proportion, it's going to be p, and so on.
Then
That's
I say
what she
claim.
means here.
Well, this is for another chapter, chapter 9. Then I says, give me some data. I put given data.
Right.
Okay, copy whatever I gave you, like in this example, sometimes
Yeah.
I'm asking you just to copy the.
Yeah, remember 9 is not on this quiz. So you're only doing 8.1 to 8.3 on this quiz.
Okay, let me stop sharing and bring my 8. Here, this is chapter 8. Parameter, variance, sigma square, claim. These are the data that I say, give me the data. Data here, then I said appropriate test, like chi-square test, z-test, t-test. Understand?
Yeah, I think we're good. Let me see if they're still, yeah, everybody's still here. So you should have addressed the question. That's the question that I've been getting the most frequently. Also, remember that parameters are the only thing that appear in your hypotheses. Okay. Never sample statistics. You never put sample statistics in your assertions for the null or the alternative hypothesis. Okay. Those are the two questions that I got the most in the last couple of days about doing hypothesis testing, and it's going to come back on the quiz as well. So be aware of that.
Okay, is everything clear now?
Anybody have any other questions? I'm monitoring. Elizabeth, go ahead. Your
I just
mic
have
is
one
open.
question. There was a problem in the homework. When we put the numbers into the calculator and we don't have a standard deviation, we used SX, correct?
Yeah, you choose S sub X. Yes. Never,
And
okay, never pick sigma from calculate menu. Never pick sigma.
and when it's asking us, you know how we do the two questions, does it give you the standard deviation? It was still considered null, right?
You
What?
only do that if you only do the two flowchart questions if you're testing a mean. If you're testing anything else, you
Yeah.
don't need to use that
Okay.
because there's only two questions when you're doing means.
Okay. Okay.
So the two things that I've been hearing the most in the last few days, not just about the quiz, but about hypothesis testing in general, are what are your parameters? Parameters we have definite choices for. Means, mu. We have proportions, p. We have standard deviation, sigma. We have variance, sigma squared. Those are our parameters. It's one of those parameters, okay? The symbols are, as you've seen, mu, p, sigma squared, and sigma respectively. Those are the symbols. The test that you use depends on the parameter you have. Now we have two tests for means from 8.3 and 8.4, right? So we have two tests for means. That's why we have the flow chart to tell us which one we're using. If you're not testing a mean, the flow chart doesn't apply, okay? You can find that in any of the videos from any of the sections where I do that. If the flow chart questions apply, I apply them. If they don't apply, I tell you which test it is.
Okay, for 8.2 and 8.3, you need the flow chart. Like when you needed flow chart to find confidence interval for the mean. Okay, chapter 7. But you don't need flow chart for proportion or a variance or a standard deviation.
Because we only have one option for that.
Yes, z-test for proportion, chi-square test for chi-square test for variance and standard deviation.
Anything else? Does anybody have any questions about anything else before we start?
You just have to, for the quiz that you see, you just have to fill in the blank. And pay attention to what method I want you to do the work in chapter 8, p-value method or traditional method. But in chapter 9, everything is going to be p-value method. Even if the book doesn't want you to do p-value method, I want you to do p-value method. We only have maybe 10 minutes or 15 minutes to go quickly over 9.4. So for chapter 9, we only looking for the mean, we only looking at z-test. So for hypothesis testing, you choose to sample z-test because it's hypothesis testing. So I should see the word test at the end of to sample z. Then you have two options under input, data or statistics. Statistics is when I give you measures of sample like X bar, S, and sample size. Then we have raw data. You pick that. You enter your raw data in list 1, list 2. You go to, I know you go to calculate, copy, X bar, S, and N for each list, and so forth. Let me share my screen again for 9.4. The reason that I'm going through 9.4 because next week you have quiz, your last quiz, which include 9.4. I'm going to go quickly over it so you have some idea what to do. Then at the when we're going to have another Zoom class meeting on Wednesday. So I'm going to go over 9.4 again, maybe examples from the homework, and you have enough time to finish the questions on proportion for 9.4 on the quiz. Okay. 9.4 is testing the difference between two means, two proportions. So we have two population. For two population, we always doing hypothesis testing difference between two proportion or two means, two variances, two standard deviation. This is the formula for test value. You don't have to use this formula because the calculator will give you the information, the number. Okay, so how do we use our calculator to do hypothesis testing to find the test value and p-value? Okay, for proportion, the only statistical test that we have is z-test, okay? Z-test. And also for proportion, we don't have input anymore. Our input includes only statistics. For proportion, we don't give you raw data. We give you a statistics. So Z distribution, and we only have statistic option. So you click a stat, you go to test. This time you select two prop. Prop is for proportion. Two prop Z test. Okay. For mean, you pick two sample Z test, but proportion, two prop Z test. There is no option for input. You enter the numbers that I have given you. Move the cursor to H1. So it has H0 colon, and then you have to pick equal, less than or equal, or greater than or equal. Not equal, less than or greater, the signs of your H1. Then you press enter. Then you go and calculate, highlight, calculate, press enter. The same steps, except this time two prop Z test, we only have a statistic option. Okay. According to the U.S. Department of Education, 51.9% of women, 46.7% of men receive financial aid in undergraduate school. The random sample of undergraduate school reveal this result. Here it is. Women, sample size 250. We talked to 200 of them. Men, sample size 300. We talked to 180 of them. At alpha equal to 0.01, is there sufficient evidence to conclude that the difference in proportion has changed? The difference in proportion has changed. It means that P1 of the first group is not equal P2 of the second group. Okay, P1 not equal P2. Oh, sorry, equal. That the difference in proportion has changed. If we didn't have the word has changed, it means P1 not equal P2.
So it's changed.
Oh,
so
it's
they're
changed.
not the same.
Sorry, it has changed. Sorry, has changed means they are not equal to each other. Sorry. Thank you, Shona.
Yeah, no problem.
The difference in proportion has changed. They are not equal to each other. Now, these are on the paper. I'm going to ask you what write the given data. If I ask you for the given data, you give me these data. But here I'm not asking you. We have z-test. Since we are dealing with proportion, we're going to pick and we want to do hypothesis testing because we have alpha. We're going to use two prop z-test. Two prop z-test. So let me go to my calculator. Two prop z-test. Stat tests. At the beginning, you have all the tests. So two prop z-test. You see that it doesn't give you option for input because we only have a statistics. X1. On the slide, I have 200. Then it says N1, I have 250. X2, 180. N2, 300. Okay. First of all, before I continue with my calculator, my claim was P1 and not equal P2, correct?
Mm-hmm.
That goes to H1. So my claim is H1. I have a two-tail test, H1. My null is P1 equal P2. So that's your H1 sign. So when it says P1 colon, I'm going to pick the first option. Okay, because that's my claim, and that goes to P1, H1. P1 not equal to P2, that's our claim, H1. That's my Z, that's my P-value. 4.33624 e to the negative 7. Don't forget, do not ignore e to the negative 7. Some students do, which is completely wrong. This means that you have to move the decimal point 7 places to the left. So your p-value is not that large. It's actually very, very small. A decimal point with 60, then 4.33624. Okay. So claim H1, two-tail test, HO P1 not equal to P2. Then I go to test value. I copy this number from the calculator I just show you. Test value, that. I move my decimal point 7 places to the left. It is the number. If I have to decide to reject or not reject null, I compare my p-value with alpha. P-value again is less than alpha because p-value is larger. P-value is less than alpha, so we're going to reject null. And our claim was H1.
Mm-hmm.
We rejected null.
So
That's our outcome. We pick a lower left box. There is enough evidence to support the claim. What time is it, Shana?
it is
45?
12:45 right now.
Okay. You see that it's similar to what we did in 9.1, except here you have two prop z-test. Two prop z-test. And are you still seeing my PowerPoint?
Yes. Okay. Yes, we're seeing the nasty formula right now.
This is confidence interval formula that you can use to find confidence interval by hand, but you don't have to do it because we can find them with the calculator. Again, we're going to use 2 prop Z int. For interval, you pick int, not the test. There is only a stat version. The calculator asks you for x1, n1, x2, n2, and so forth. And if I have not given you x1 or x2, and I only have given you n1 and n2 with the p1 and a p2, you use this formula because we know that p hat equal to x over n. And then x would be p hat times n.
Okay. Are you there?
Oh, sorry. In a nursing home study, the researcher found that 12 out of 34 small nursing home. Okay. Okay, first, okay, let me, this is, okay, I still have time. So I call small nursing home group 1. My N1 is 34, X1 12. This is not P1 hat, okay? So small nursing home had resident vaccination rate of less than 80%. That's just a topic of our study. While 17 out of 24 large nursing home had a resident vaccination less than 80%. So large nursing home, I call them group 2. This is X2 and N2. We want to find 95% confidence interval. So we have to use z-test, 2 prop z-test. Here it is. Small nursing home, group 1, N1, 34, X1, N2, negative 20, N2, 24, X2. Then I went to test, stat, test. I pick 2 prop Z int. I enter my N1, X1, N2, X2. It gave me this confidence interval, okay? I don't like this confidence interval because I'm talking about proportion, percent. Percent is not negative. Proportion is not negative. So how do I correct my answers? So what I have to do is change my group. So I change my group. This time I called large nursing home group 1. Look, before large nursing home was group 2, N2 was 24, X2 was 17. I changed the groups. Large nursing home group 1, so M1 is 24, X1 17. Small nursing home group 2, N2 34, X2 12. Then I went to stat, test, 2 prop Z int. I entered these numbers. When they asked me, it gave me the positive results. Okay, it gave me 0.1128 on the first number, 0.5980 the second. Okay, then I change my decimal to percent. So make sure if both numbers are negative, you change for proportion. I'm talking about proportion. Switch your group. But if you end up with something like this, negative 0.1234, less than, let's say, P1, minus P2, less than 0, okay? You end up with an interval like this, or negative 0.1234, comma 0, okay? If one number is negative, the other one is positive 0, all you do is just you do the following. You write put 0 on the left side. Then you say P1 minus P2 less than, change this negative number to positive. Okay? Because that's, you are telling me that if one is negative, one is zero, just put zero on the left, make that negative on the left positive, put them on the right. You are telling me automatically that you switch the group, and this is the correct result. Is that clear?
Mm-hmm.
If one of the numbers is negative, and usually you end up with a negative number on the left for proportion and zero on the right side. So you just switch them around, make the negative positive. Okay, that's all for today. I hope you put your name on the chat. Shauna I don't know if when she has a tutoring, if she doesn't have a tutoring, she can talk to you through inbox messages or email. And I'm also checking I have office hours from 1 to 2. So
I also dropped in under week 15 on Canvas. Under week 15 on Canvas is the critical values, the p-values, and the test statistics that she was talking about earlier. I dropped a
the
copy
links.
of that
Oh, okay, good. Thank you, Shauna.
into the chat. So please be sure and pick up that document.
And did you put the copy of the formula sheet?
The formula sheet? No, I can do that, but I picked up the CC, the other one.
Okay, that's fine. I can
But we can
everybody.
push it out. We can push it out as a Canvas message.
Yeah.
As well. We'll push it out. If you want to stay behind and talk to us, you can for a few minutes. Remember, Professor Nikdel has an office hour directly after this meeting at a different link. Use the Wednesday office hour link. We'll be there. Okay. Have a good Thanksgiving, everybody.
Yes. Have a nice Thanksgiving. Okay.
Thank you, you too. I just
Yeah.
have one more question. I'm sorry.
Yes.
For the tell test, we always use H1, correct?
Yes. Always H1.
Okay, perfect.
Okay.
All right, I think.
Good luck. Bye.
All right,
Mhm.
thank you.
Welcome,
Have a good
Elizabeth.
one.
To stop recording here.